The cooling process of a mold has a significant impact on its cycle time as well as on part warpage. Parts with complex shapes need curved cooling channels with constant distances from the edge for optimal cooling. Usually, these cannot be created using typical milling and drilling. Version 13 introduces a new function for designing conformal cooling inserts using 3D printing technology. The core insert of this part is already designed. We will now design the cooling channels of the orange segment. The orange segment is stiff and narrow, so first we will analyze it to determine the size of the cooling channels we want to use. Using the mesh offset option, we select the orange faces, define the cooling offset. The offset body is colored in yellow. We hide the core and try several values until we get the maximum possible value, 4 millimeters in this case. Next, we select the channel shape. We start with a circular section with a diameter of 3 millimeters, which is more than the section of a 6 millimeter baffle. The section area is about 7 square millimeters. We then switch to ellipse with the same section area, as it has a greater cooling efficiency than a circle. We define the cooling segments as lines, the corner as 3 millimeters, and start defining the cooling channel locations. When we click on the next point, the system automatically rounds the channel by 3 millimeters. We now switch to spline segment type and continue the definition of the cooling channel. We change the rotation angle as needed until it looks right. At this stage, we use the visual analysis option to make sure we are not too close to the part. We start with an initial value of 2 millimeters. In some areas, marked in red, the cooling channel is too close. When we change the distance to 1.7, all the red marks disappear. Version 13 answers a need for designing complex conformal cooling channels quickly and with complete confidence.